Hi, my name is Tim. I'm Senior Application Specialist at HCRSoft. In today's webinar, we will focus on true time-saving tools in custom tools. With me today, I have my loyal wingman, Francois Simon, who will answer your questions. And you can use the chat box in the GoToWebinar panel. I will make room after the session for more questions to let you follow this presentation better. And we expect the webinar to be somewhere in the range of 25 minutes, and the webinar is being recorded as always and will be made available online later on. Okay, let's get started. So these bullet points are very generic, and there can for sure be many more time consumers in a design process. From the pure CAD design point of view, these are, however, all somewhat overlooked in the broad perspective. We have a pretty good understanding of how quick we can create 3D geometry, but on top of this comes layers of additional tasks, like simply just making drawings, which in many cases could take equal the time of creating the part file itself. Reusing a part or an assembly by copying it and then relinking drawings is a big task if it's done natively in SolidWorks and Windows Explorer. Creating bench sheets, cutting profiles, cut lists for manufacturing, printing files and converting files, and making different types of reports, all are time-consuming things that you don't want to mess around with. And these are actually tasks that a CAD engineer is going to face on a daily basis. So in custom tools, you have a bunch of tools to speed up many of these tasks. You could say that we minimize your manual task for you to maximize the productivity time spent in CAD, and then the quality and the revenue is going to increase in your design. If you have a part and a drawing, you can copy and reuse. With slight modification, you can use the Save As Copy option in custom tools. Same is true for a full project, like an assembly, just use copy. If you want to export the bill of materials to Excel or to an ERP system, with SolidWorks, or with custom tools, I might say, you can create this with basically 3 mouse clicks. Same for printing and file conversion. In no time, the process is started and you can focus on something else. Where used is a great tool if you anticipate changing a part, so you know the impact up front. If you don't know where a file or an assembly is actually stored, you can just click on it in the graphic window and press Explore and go to the file in Windows Explorer. And these are all small helpers with a big impact when combined in your daily routines. But with no further delay, let's get on with it. Actually, before we start, we have quite a lot of Danish attendees. Thank you very much. That is nice to see. I want to make a small commercial break, you could say, because I'm not sure if you know, but October 2nd, we're going to host a seminar for our customers in Silkeborg. So you can go into Custom Tools Info and you can join us at the Custom Tools World for End Users. So you can read more and you can sign up from in here. And mind you, it's free to attend. That was just a word from the sponsors. Anyway, let's get on with the live demo. So I'm going to open up a part file. And this part file actually already have a drawing. In case you didn't know, you can actually just use the open drawing from Custom Tools and it will find the drawing for you. And we don't basically care if it's the same name or if it's stored the same location. When we are saving files in Custom Tools, we keep track on these references. So just a small tip for you in case you didn't know. Now, this one is a sheet metal file. So maybe I need to create a DXF outline and maybe I need to create a bench sheet. With no hassle at all, I can just click 2 buttons. So cutting profile first, and then bench sheet, and then I will actually have created quite a lot of work in just 2 mouse clicks. So the DXF sheet is going to create the outline of the DXF file. And before I go into that, basically I want to show you, we have some countersink holes coming in from this side and from the back side. So on two sides of this part, we have countersinks, and we also have some threaded holes. So a 3/4 circle is included in this one. But if you look at this one, we actually cleaned it up perfectly, so it's ready for laser cutting. We removed that circle that is around this hole, and we removed these 3/4 circles that indicate there is a thread. On top of that, we set this view scale to 1:1, and further we removed the sheet format itself. So this is just as clean as you can get for a flat pattern. Our bend sheet was a small project we did some time ago, where the lower left corner to the upper right corner, we calculate the bounding blank that is required. So we have a ordinate dimension where we can see the extent to top and side, obviously. And then we also insert dimension for the bend lines, as well as inserting the notes up 65 degrees, radius 0.74. So everything is quite easy to use. And I mean, just these two sheets alone would have taken some time to create if done natively in SolidWorks. I'm going to create a copy of this one, but let's first save it. Okay. So maybe you need to do a design copy. For some reason, you need to have a small change in this part. So you would normally go and copy the part file and then the drawing, and then you would open the drawing and link everything together that way. But with custom tools, it's quite more easy. You can just go to Properties. You can select an action point to save as copy. And then you can find a new part number for this one. So I'm using a sequence. And yeah, just let us use that one. And we can actually change the color just so you can see it. So now I'm going to create a new copy of this one. I am using Save as Copy. So hitting OK will prompt to store the file, and I'm going to save that. And now, because Custom Tools knows that we had a drawing for the original part, this one in screen, it will suggest to copy the current drawing as well. So relinking the new drawing to the new part file. And obviously, I would say OK to that. Saves me some work, right? So now I have created a new file and drawing, part and drawing, and I can open up this newly created document looking like this. So I don't need the original part anymore. I can just close that one. Maybe I want to create an assembly out of this one. That would be a natural next step. So I'm going to make assembly from the part file and just insert it. This is just plain SolidWorks. And I'm going to use Custom Tools to save this new assembly. So going into Properties, it already picked up a sequence, and I can type in description and whatnot, but I'm just going to save it as it is. And save that. That's good. Sometimes you need to have one more part with a slight change. And this is easily done from within the assembly as well. So if I select the part file in the graphics window or from the feature manager, I can go to Properties again, this time creating a copy of the existing part file. So again, under the action, I can select Copy as New Component, fetch a new part number for it, and I could even change the color of it. And hit OK. And again, it's going to ask to save it and then detect there is a drawing existing already. Prompt if you want to save the new or copy the drawing to a new drawing and update the drawing. And I want to say yes to that, obviously. And I can then move this off a little bit. So now I have two parts. Now, might want to save that. For some reason, I'm not entirely satisfied with this one. I want to try something out, so I'm going to swap this one and try a new idea. So this part file I will select, and I will go into Properties. And basically what I'm going to do is I'm going to replace this one with a new part file. So again, Action, Replace Component, pick a sequence. And maybe give it a new color. Okay. Same steps as before. I'm going to save the file. Custom Tools knows that I have a drawing for it. Prompts me if you want to copy the drawing to the new part file, so you have everything intact. And of course, I want to do that. So now my design is completely different from what I started with. These two parts are not the ones that I started out with. So I can save that one, and I'm quite happy with my design. Now, we also keep track of references. And this is true for basic flat file use. So if you are storing files on an archive server, not in PDM, we keep track of everything. And if you do PDM, then we keep track of that as well. So if I look at this part file and go to where used, I know that there is a drawing and there is an assembly. So all of these references are kept intact. So if I wanted to change anything, then I would know up front, if I change the part file, okay, where is it going to be used, and would it be smart to make a new instance, a new item, instead of modifying an existing file. So just to keep that in mind, that we do support that as well. Okay, I want to open up a new assembly file. Because now you have seen that we can create copies of parts quite easily. So when it comes to larger assemblies, then we also have you covered. So in this case, I'm going to take this existing design and run the copy. And you can actually use copy on a part as well, but I do recommend using properties and then save as copy when it's just part and drawing. But for an assembly, obviously, just go for the copy, and you will see why. In this one, I have a rather complex rule for saving my files. I am using unique file name for part and for assembly. So I need to swap these to part and assembly. So for this one, I'm going to use document number, actually a sequence from PDM using. And then I'm going to select the assembly, and then I can select a name for my assembly file. I could also go back to the model scope itself and then type in a new description in this field, but that would update all of the parts being used. So description might not be the best one to mass update, but if it could have been a customer name, for instance, that would make sense to update. In the right side of the screen, you select where you want to store this new file. And I have a folder called 10,000 on my desktop, so I'm just going to drop it in there and then generate file names. And you can see in this window that the original file name was 89.406.407 and so on. And the new files are going to be named like this. And we can even see that the drawing is going to take the same name as the assembly in this case. In this one, we can also import copied files to Custom Tools database, makes them searchable. We can exclude design library files, toolbox parts, and we can select to update drawings. And I do recommend updating drawings because then everything is just as it should be. So hitting OK is going to start the process, and we are going to copy these 6 files and the single drawing, and everything is going to be up to date. And when the copy has completed, Custom Tools will prompt if you want to open up the copied version of the document, and I want to do that. Okay, so now basically I'm done with the old assembly, so I can close that one out. I don't need to save anything. And then I want to show the export at this point. So in the export window, because this one is actually quite a lot of different files in one. So the first one, as you see the table, is Weltment. We have cut list with 22 different members in it. So if I look at these ones, you can see I have a leg pipe, I have crossbars, I have a default part, it's just an extrude, this connection, and I have a foot plate and a table plate. For these ones, it's a multi-body sheet metal file, so we have bottom, 2 sides and 2 ends, and so it continues. So we have some mixed parts in here. If I run the export, no need to save it. Yeah, we also do nav export. I'm not going to show you that right now, but let's go for the Weltment support. So the Weltment support, or the Weltment export, I should say, is going to take a little bit of time to calculate. We can actually speed this up, but then you lose a little bit on the benefit. So we are right now creating some preview images, and you will understand in a second. So that is my top level. Nothing fancy about that. Then I have my part file, my Weltment part, I should say. And you can then see we have all of these different items coming from the cut list. So we support exporting the cut list. And in this case, you can see that we have a leg pipe, isolated the single body. And we can see that this leg pipe is 33.7 times 4.0. And it has a cut length of 750. And we can go through all of these individual ones, and we can see the preview is unique per item. The connection spider, looking like a folder icon, is the part, and we can see the individual image of that one as well. And that is true for foot plate and table plate as well. Then we go to the next one, which is our multi-body sheet metal file. And I'm not entirely sure why, but I think we should isolate, but it's not working at current here at least. But you can see that we have a bottom, side, and end plate. And we calculate the total cut length, how many cuts, and if it has any bends. And we could actually insert the number of bends as well to this report. The next one, total cut length, 235, and it does have bends. And the same is true for the latter one. And you can see that we actually have everything in place. I'm not going to run this export. I'm going to add some more to it. So from the search, I have a bunch of files, and if I'm fairly confident what I'm looking for, I can actually type in that it's 457. That is at least part of the number that I'm searching for, so I can conduct the search again. And then my Weltment structure comes up, and I can actually drag and drop into my assembly. It is going to ask me, because more configurations are found, which one I prefer to insert to my assembly. And I just go for the as machine and hit OK. And this way we can build assemblies quite fast. So now I'm going to just orient this ever so slightly freehand. Oi, what is wrong? Okay, not sure why my mouse gestures are not working, but that's how it is. So here is a very nice assembly. I have this funny Weltment structure that I created. And if I go to the export again, this time let's save it. It is going to calculate again these preview images for the Weltment cut list items, as it clearly states in this dialog. And it's going to take a bit of time, but imagine doing this by hand. Then I would imagine that creating this type of report would be significantly longer. But here it is, so we can see everything created nicely. Now, this part file that I created was actually made from a solid block. So this one was the skeleton, and then I created all of the structure on top of that. So I really don't need this one, so I can exclude it from the bill of material and then export. Yeah, let's go. And we're then creating the Excel file. And that opened up on a different window. Just a second. So here it is. We have the top level indicated by nice gray color. So you can see that this is an assembly, and then all of the parts are included as well. So we have the part file and then all of the cut list items. This is true all the way throughout. And we have not exported this solid block that I created the structure from. But if you did, you could actually just use standard Excel and hide something in here. But anyway, this is our basic report. If I want to, I could also select to export to NAV. So NAV is going to be the place where I upload these files, and I can see that all of these are detected as new items. Now, I'm not going to get into details on the NAV at all, but I'm just going to export it and see if it's going to work. Yeah, export that. Okay, so I forgot to set a base unit of measurement of one of these parts, this one. But apart from that, everything was uploaded. So I need to create piece for unit of measure on this one. But anyway, it's working. Maybe I would like to do something more with my assembly. So I'm going to insert component, and these two I will put into the assembly as well. Rebuild and save the document. Okay. Now is the time where I would probably run print and file conversion. So I will go into custom tools. I will go to print convert, and then I'm just going to do some quite simple tasks in this case. I don't have any printing rule defined. I could actually create one right now, but printing wouldn't make sense in a webinar anyway, so I'm just going to skip that and go directly to batch conversion. I would like to have PDF file of my design. The PDF file is going to be, in this case, merged into one PDF file. I will create all the sheets that are found, except for those called DXF, because I don't want to have the DXF sheet printed out. I would also like to have a nested DXF of all of the sheet metal files. And actually, if you had bunch of files in this list, you could right-click and clear selection, so nothing is selected. Then you could go to the filter, say, I want to have parts that are only sheet metal, and select those. So this way you can quickly filter this list and only process sheet metal files. And maybe I would like to have quantity. I'm not even sure if I set that up on my PDF or my drawing template, but let's see. So I'm going to hit OK. And now it's going to batch process PDF from drawings, and it's going to create a nested DXF file. We could also create individual DXF files, but I'm quite sure that you probably know that already. So I'm just going to show the nested layout instead and show how much control we actually have over the overall design and task process. And it's working like crazy in the background, and we like that because as long as the computer is doing the work, we can actually drink coffee or do something productive. And again, doing this manually would take quite some time. And I do know there are other tools on the market that can do similar things as we're doing, but I mean, you get the complete package and you get full control over your things using custom tools. Okay, so there was an issue with one of the part files. That happens from time to time, but let's see what we got. Okay. I don't think that matters. It's one of the part files. Let's ignore that one. So looking at the Explorer window, if I look at my desktop, this is where my converted files are now created. So it didn't actually create the nested one. I'm going to have to rerun that one. But it did create the PDF file. And no, I didn't have quantity enabled. But you can see everything was merged into one PDF file, nice and easily. And I do want to create the nested file. So I'm just going to run that one on its own, removing this guy, and that should be okay. I guess it's just the demo effect. I mean, I have been running this consecutively and having very few issues during this process. So now everyone is watching, and obviously you get an error. I guess that is Murphy's Law. If it fails again, I'm quite sure it's because the assembly is open in the background. So it looks like it's working. You can actually see that these sheets are created with multiple views on them. So yeah, let's open up and have a look. So again, on the desktop, created these converted files, and right now, 10:27, yeah, okay, 1 minute after, is the DXF folder and the nest folder. In this one, we have created these new files. We can see that it comes from this part file. The part file is made from plain carbon steel, and it's 2 millimeters thickness. And this one is plain carbon steel, 3 millimeter, brass 4 millimeter, ABS 2 millimeters. So let's open up one of these. And you can see what this merge DXF is actually all about. If you recall, in the assembly we had 2 of these boxes, so that means we need 4 of the sides with a total cutting length per item of 1106. For the end plate, I also need 4, and cutting length for this one is 656. And if I scroll this way, you can see that this is the bottom plate, and we need 2 of these to create 4 boxes. And this is true for everyone else of these ones, so maybe do the brass. Not going to contain a whole lot, just 1 item because only 1 part was in brass. This one will contain 2, so we have these carbon steel, one was in some brown and yellow, if I recall correctly, so these are also created. If I go back to SolidWorks, and I'm not entirely sure where items are located, I can just click on anything in the graphics window and I can press the Explore button. And that would open up to the folder location, highlight the file, and then you have found the missing part and you can clearly see where it's located. And I am fully aware that you can go into File, find references, find the part you need, and then copy that path or whatever. But I mean, point and click is quite intuitive, I would say. Okay. That is all that I had to show you today. Our next webinar will be about all the new stuff that we added to Custom Tools 2020 version. For the Danish audience, you can join on October 2nd and see that one live in Silkeborg, or you could join the webinar that will take place on 10th of October, same time as today. We are open for questions when the recording is stopped, but first I want to thank you all for attending this webinar, and I hope to see all of you for the next one. Thank you and have a nice day.
We are in the life-saving business. We kill your routines before they kill you.